Now we want to talk about congruent triangles. Now, what do I mean by congruent? Well, I mean that all the corresponding sides are the same length and all the corresponding angles are the same measure. So let me illustrate it here. I've got this triangle ABC. So this is a triangle ABC. Okay. And then over here, I've got triangle, let me see here. I've got triangle DEF, okay? ABC and DEF. And if I say that these two triangles are congruent, what I mean is that the corresponding sides are the same. That's one thing. So in other words, segment AB is equal to segment DE. Then this segment is congruent to this one. So I mean that BC is equal to EF in measure. Okay. And then finally, this one down here, they're also the same length. So I have AC is equal to DF. AC is equal to DF. Okay, so that's part of it. All the sides are the same. Now also, all the corresponding angles are equal. So the measure of angle A is equal to the measure of angle D. Okay, and then here's B. I'll put two little things here. Two little arcs. Okay, two little arcs here. So the measure of angle B is equal to the measure of angle E. And finally, put little three here so I can identify which is which. The measure of angle C is equal to the measure of angle F. Now, this is what we mean by congruent. Now, something we want to pay attention to here is the order. Notice that I've written this as triangle ABC and this triangle as DEF. Now, I could have written this triangle another way. I could have said, okay, this is the triangle FED. But I wouldn't want to do it that way because the idea is I want to have the corresponding angles and sides lined up. Notice that A is congruent to D. B, the second, is congruent to the second over here, E. And C is congruent to F. See? You can see that here. Likewise, it kind of looks like that with the sides as well. I've got AB and DE. See the way it's lined up? AB over here and DE. And then I've got BC to EF. And then I've got AC to DF. Now, so it's important if you're talking about two triangles being congruent, the order in which you write the letters. Okay. Now, it's not just triangles. When we talk about congruence and say the sides are the same length, the angles are the same measure, it's not just triangles, it's shapes in general. Let's look at, just for practice here, let's look at this thing. This is a quadrilateral, okay? And we're saying that these two things are congruent. Now, let's see if we can figure out what's corresponding here, okay? So this thing is turned around and we want to figure out, okay, which sides are congruent to which sides? Well, notice that it looks like, okay, this angle N is congruent to angle E. So angle N is congruent to angle E. Uh-oh, it's the way this is written, they've got two F's here. So this right here should be angle E. There it goes, like that. Okay. I think I chopped it off. They didn't do anything. I think I chopped it off and I clipped it out. Then angle P is congruent to angle F. Okay, so this would kind of help us to know what's what. Angle L, let's do 3, is congruent to angle G. And then finally, H and M. Okay, for these things. Yeah. So there we have our congruents, our angles lined up. Okay, so let's look at it a little further. Now, also, it looks like this. Let me change colors here. LM, it looks like, is congruent to GH. GH, okay? So we're kind of matching these up. And we could keep going like that, but notice what we're trying to do is we're trying to find X and Y. Okay? So let's see what we've got here. We've got 2x minus 3. And we need to set that equal to something. Okay? So that's GH. I mean, we can set that equal to 8. See, because those sides are the same length. Ah, there we go. We've figured out what sides coincide. Okay? Okay, so we've got 2x minus 3 equals 8. Now let's see what else. We've got 7y plus 9 equals, let's see here, that's got to equal 72. Yeah, 72. Ah, now this is suddenly got a lot easier. So we've got 2x is equal to 8, 9, 10, 11. So x is equal to 11 halves. Now, by the way, I'm going to leave that as 11 halves and not write it as 5 1/2. You know, I'm not going to write it as mixed number or anything like that or a decimal. I just prefer to leave it that way. And then we've got y is equal to, let's see here, this would be 63 divided by 7. 63 divided by 7, which that would equal 9. Okay, so y is equal to 9. So we found x and y there by understanding that these two shapes are congruent. Now, of course, we're dealing with triangles, so we want to start looking for ways to show that triangles are congruent. And the first thing we're going to look at is this third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Okay? Now, this makes a lot of sense because, remember, all the angles of a triangle have to add up to 180 degrees. So if you add up all the measurements in the triangle, 3 of them, they have to add up to 180. So if you have two triangles in one, or two angles in one triangle equaling the two angles in another, the measures being the same, then the third angles, they both have to add up to 180. In other words, in this triangle here, this angle and this angle plus this angle have to add up to 180. And over here, this angle and this angle and this angle have to add up to 180. Well, if these two and these two are the same, these two must be the same. Well, if these 4 are the same. Okay, if those match up, then these must match up. Okay. Now, so it makes sense. Now, let's see how we could use that. Let's look at these two triangles here and see if we can somehow use that to figure out what this is. 2x plus 3. 2x plus 30. Well, notice that this is a situation where you have two triangles that have the exact same measure, or two angles in each. Well, you have two triangles and you have, let's look at this. The measure of angle R is equal to the measure of angle N. Okay, so you have that. You have the measure of angle S is equal to the measure of angle L. Ah, two angles. Two angles of a triangle is have the same measures to two angles of the other triangle. Therefore, the third angle is the same. So in other words, this angle right here is the same as this one in measure. Well, we want to figure out what S is. Now, remember, all three angles have to add up to 180. So let's figure out what the measure of angle M is. Well, it's going to be 180 minus 55 degrees plus 65 degrees. In other words, I want to see what's left. So I've got 180 minus 55 plus 65. And that gives me 60. So this right here is 60 degrees. That means that 2x plus 30 has to equal 60 degrees. Okay? So that means that 2x is equal to, let's see here, 60, that'd be 30. That means that x is equal to 15. Yeah, so there we have it. So by knowing that two angles from one triangle are each congruent to the corresponding angle in another, we can determine that the third angles are also congruent. And that helped us in this case to figure out what x is. Okay. Now, let's look at this one. What I want to do with this one is I want to prove that these two triangles are congruent. In other words, I want to prove this. I want to prove that triangle RQP is congruent to triangle NQM. That's what I want to prove. Now let me see if I've named these properly. Okay, let's just think about this. So I've got angle R, or let's look at this. Angle P needs to be lined up with angle N. Ooh, it's not, is it? Angle P is not lined up with angle N. So I need to rewrite this a little bit. Okay, so you see, you can't just be sloppy like I was there. So let's see what we've got. Let's be very careful in how we name these. Okay. Okay. Now, I'm going to start with P in this triangle over here, and I'll start with N in this one because I know those angles line up. Now, I'm going to go up to R. Notice, and over here I'll go to M. Okay, see that? Because I'm making sure that PR is lined up with NM. And then the next thing I do, I just go to Q. Okay? Now notice that, whoops, I didn't put a Q there. There we go. So now I think everything is lined up. Now I want to show that these triangles are congruent. And it's already given that three sides are congruent. That's already given. Plus, we have one angle is congruent. Okay? So we know that. Now, remember what we need. We need to show for triangles to be congruent, all three, it's got three congruent sides, and, well, you've got two triangles. The corresponding sides, all three corresponding sides are congruent to each other, and also the corresponding angles are congruent. Well, you might say, well, we only have one corresponding angle. The sides, no problem. Well, look at this, though. This right here, these are congruent also. In other words, RQP, okay, look at this. Or let's do this. Let's do PQR is congruent to NQM. Okay. Okay. Those angles are congruent because, and you might ask, well, how do you know that? Well, because it's a vertical angle. Okay. So you train yourself to spot these things like, Okay, so this is these are vertical angles. Therefore, those angles are congruent. Oh, as far as the naming goes, I'm looking at this. It might have been better if I said RQP is congruent to MQN. That might be, I don't know, that might be a better way to order it since the way I ordered it over here. But you get the point that we have these angles, we're showing that they're congruent. Now, we have two angles of a triangle congruent to their corresponding angles in another, plus all three sides are congruent. Now, you might say, well, how do we know all? Well, look, okay. We have this angle congruent to this one and these two congruent. Therefore, this one is congruent to this one, okay? Because third angle theorem. If you've got two angles congruent to their corresponding angles, then the third angle is congruent to its corresponding angle. So you have three angles and three sides congruent, okay? In other words, the idea, the trick was, we show that these two angles are congruent. This one and this one. We already had this one and this one. And we had this theorem that says the third angle then is also congruent. Okay. Okay, now let's look at a proof here. We've got some given information and we want to show that triangle AEB is congruent to DEC. So let's see what we've got here. I've got AEB. So I've got this triangle here. We put it in pink. Okay. Is congruent to DEC. This one down here. Okay, so those are the triangles that we're dealing with. Now, they give us some information, so we want to see if we can prove this. So let's just do an old-fashioned two-column proof. Here's statement, and here is reason over here. Now, first of all, let's just write what we're given. We're given that AB is parallel to DC. I'm thinking we're going to have to use this. AB is congruent to DC. Okay. And E is the midpoint. The midpoint of BC and AD. Okay. Now, this was given. So all this stuff was given to us. So we don't have to worry about that. Now, why did they give us this information? Well, when they give us this information, before we write down anything, let's just think about what we have here. Immediately, we know that we have a parallel line up here, and a parallel line down here, and these are cut by a transversal. Okay? Okay? That's something that we have, that we notice right away. Now, we also notice that BC and E is the midpoint of BC and AC. So let's just do this. We know that this and this are congruent. Okay? So we've got two sides are congruent. Now, let's see what else we can do. Before we even write down anything, we're just trying to structure in our mind and get it straight in our mind what we have here. And so far, we have two sides. Now, another thing we know is that this angle right here and this angle right here, these are vertical angles. So those two angles are congruent to, those angles are congruent to each other. Okay, so I'll go ahead and mark that down right away. Okay, now let's see what else we have. Now, what about this angle here? What's it congruent to? Well, what about this angle? See, these are parallel lines, cut by a transversal, and these are alternate interior angles. Oh, because this is the transversal. So those two angles are congruent. And then dig this. The same reasoning makes these angles congruent. Okay. Okay, so there's what we have so far. Now let's see, we're almost there. Look, E is the midpoint of BC, okay? Oh, and AD as well. So this means that these are congruent as well. So let's see what we've got. We've got in each triangle, each angle is congruent to its corresponding angle, and each side is congruent to its corresponding side. Oh, so there you have it. Now, what you would do is you would just simply write out the reasoning. So I was speaking out loud, and you would go through here and you would just write the observation and the reason. Okay? But my idea with this proof is just to kind of show you, okay, before you do the proof, get it straight in your head where you're going, what path you're going to take. Okay. Now, one of the things that we want to take note of just here at the end is some of the properties of congruent triangles. And, you know, some of it's just common sense, of course. The reflective property, or reflexive property, that every triangle is congruent to itself. Yep, that makes good sense, right? A triangle has the same measure of angles as its own angles and the same sides. Yeah, so that makes sense. The symmetric property of congruent triangles. In other words, it goes both ways. Triangle ABC is congruent to DEF, then DEF is congruent to ABC. So that makes sense. And the transitive property of congruent triangles, if ABC is congruent to DEF and DEF is congruent to JKL, then ABC is congruent to JKL. So just some basics there. Okay, alrighty. I've talked long enough. So here are a few problems that you can work on with congruence.